Okay, today we're going to be doing jump game, which is LeetCode problem 55. Okay, this problem states you are given an integer array nums. You are initially positioned at the array's first index, and each element in the array represents your maximum jump length at that position. Return true if you can reach the last index or false otherwise. Well, in the first example, we see nums as 2, 3, 1, 1, 4. So basically what they're saying is you start at index 0, which is 2, and then you have two jumps. So you can jump to the 3, and you can jump to the 1. Now when you get to the 1, you can jump once. You jump to this one, and then this one has a jump to the 4. So in this case, you can reach the end of the array. You can also, the explanation says you have two jumps, so you jump from take the first jump to the 3, and then forego your second jump and just start at 3 and do 3 jumps to the 4. So that will return true. In the second example, 3 jumps will get you to 0, 2 jumps will get you just to 0, and 1 jump will get you to 0. So there's nothing that can get you to the 4, so that will return false. So the way we're going to tackle this is we're going to start at the end of the array, because that's the number you're trying to get to. So in the first example, the 4 would be your goal. So then we backtrack 1, and we see that, 1 can reach the 4. So this jump has 1 jump, it can reach the 4. So then this becomes the new goal. We only have to get to this 1, because we know this 1 can get to this 4. So then we backtrack 1, and that can also get to the 4, because it goes 1 to this 1, which is the new goal, and then to the 4. We backtrack to the 3, which only needs to get to here, because this is our new pointer, our new goal, I guess, if you want to call it. And so this moves 1 space, and it's already there. And then the same, and because that is successful, this becomes a new goal. We only need to get to the 3, and the 2 can obviously get to the 3. In the second example, we start with the 4. 0 will not reach the 4, so we keep the 4 as the goal. 1 can't reach the 0, so that again the 4 stays the goal. Same with the 2 and same with the 3. So 4 will always be the goal. The pointer never moves down the array, and this will return false. So how do we code this? Okay. So basically, we need to get the last number, right? We're going to start at the end of the index. So get the last number in the array. So it's just I'm going to call that goal, and it's just going to be nums length minus 1. So if we use the first example, we see that the goal is 4. So now we just need to loop backwards through the nums array. So int I equals nums length minus 1, I is greater than or equal to 0, and I minus minus, which will decrement I on every iteration. All right, so what we want to do is we want to determine if the current index can reach the goal. If so, move the goal to the current index. So if we go down in here, we see, okay, if so I is 4 plus nums of 4. So index 4 is actually number 4. So 4 plus 4 is 8, is way greater than the value of goal, which is 4. So then we assign goal to I. We don't assign it to the addition between I and nums I. You just assign it to the goal, which means basically this is just the first iteration, which we can't move. You can't move the goal left or right on the first iteration anyway. So this just remains 4. All right, and we go through it again. So now I is 3, and nums of 3 is the number 1. So if we have 3 plus nums of I, which is 1, so we have 4, is greater than or equal to goal, which is also 4. So in that case, we're going to assign the goal to I, which is in this case is 3. So this is what I showed in the first example. We literally moved the goal to index 3. So 0, 1, 2, 3. So now the goal is just this 1 here. So we'll go through this again. I is 2. Nums of 2 is also 1. So 2 plus 2 is greater than or equal to the goal, which is true. 4 is greater than 3. So the goal becomes 2. So 0, 1, 2. So we move to this number 1. And you'll see we'll just keep doing that. All right, so nums I is 1. 1 plus 3 in this case is 4, which is greater than or equal to the goal of 2. So we'll assign the goal to index 1. So now the goal is 1. And we iterate through this last iteration of the loop because I is now 0. So 0 plus nums of 0 is 2, is greater than or equal to the goal. The goal is 1, and so we assign goal to I, which is index 0. So with the goal being equal to 0, meaning we made it to the very first index, then we return true. All right, now let's try it with the second example, which returns false. So again, the goal is 4, nums length minus 1. So we're going to iterate through again. So 4, goal is, our I is 4, nums of I is also 4, which is greater than the goal, which is 4. So 4 plus 4 is 8, is greater than the initial goal of 4. So that's fine. On the first iteration, like I mentioned before, you have to stick with the current goal because you can't move it left or right. All right, so goal remains 4. So now we're going to go to I equal 3. So 3 and nums 3. So nums at index 3 is 0. So if we have 3 plus 0, that is not greater than or equal to 4. And so we bypass setting the goal to index 3. And then you'll see the same thing is going to happen down the line. So now index is 2. And 2 plus nums of 2, which is 1, is 3, which is not greater than the goal of 4. The same thing with I equal to 1. 1 plus nums of 1 is 2. So 2 plus 1 is 3, not greater than or equal to the goal. And finally, we have index of 0, which is 3. So 3 plus 0 is 3, which is not greater than or equal to goal. And so we reach the end of the loop, and goal is not equal to 0. It's still equal to this last element, 4. And so that returns false. Okay, so we just ran those. So those passed the 2 test cases. So now let's submit it. And look at that. It even runs fast, 99.98. So that's pretty much all I have. Thank you for watching, and we will see you next time.